Want to create an AI but you don't know how? By the end of my reinforcement learning playlist, you'll be able to create your own AI, which you can then use to play games for you and beat your friends' records easily. But in this video, I'll explain what is reinforcement learning, why you must know about environments, and how you can create them yourself. Let's dive right into it. Reinforcement learning is a form of AI that learns through rewards and punishments. For example, if you want an AI to move to the right, you can punish it for moving left and reward it for moving right. The AI will try to choose actions that will give it the maximum possible reward. But how does reinforcement learning actually work? There is an environment and the AI agent. The environment gives observation to the AI agent, which is the information that the AI needs to choose action on. For example, in 2048, this will be the board. And in previous example with robot, it would be the direction to move to. Then the AI agent chooses an action, which in 2048 game will be up, down, left or right, and then the environment returns the reward that corresponds to this action. In this video, we will be making a very simple environment, where the observation is one number and the biggest reward is given when AI's action is the same as observation. For example, if the observation is 7 and the AI chooses 4 as an action, we will give it a slightly negative reward, for example minus 0.1. But if AI chooses 7 as an action, which is the same as observation, we will give it a big positive reward, for example 1. The actual value of reward doesn't matter, only the ratio between all the rewards matters. Time for coding. We will first write a code not as if it was an environment, but we will just write the game mechanic itself. This helps when you're working with really complex environments, and it allows you to debug it before training a model. We will first import the dependencies, which is just the random library, and it will generate a random target number. Then we will define a target number variable, assigning it a random value in range 0 to 9. We will need to create a reset function, which will reset the target number by giving it a random value in range 0 to 9. Now we can call the function to make sure that the number is reset. The only thing left is the game mechanic. We need to create a loop, which will first take user input and check if it is equal to the target number. If yes, then indicate success and reset the number, else indicate failure, and continue asking for the correct input. Let's check the code. As you can see, the code generates a new target number when we write the same integer as an output, and if we are incorrect, the code continues to ask for the correct input. Now when our game code is written and checked, we can transform it into the actual environment. I will create a new code that I will call something creative, for example environment. First, you need to install the gym library by executing this line in the terminal. Now let's import the dependencies. We will need the gym library that I'll explain later, and the same random library. Now we need to create our game class that will be our actual environment. Our environment class has 3 main functions that we will need for now: the init function, the reset function, and the step function. We will start from the reset function. It is a function that actually restarts our environment, and it is called when the game episode is ended. And in our case, it is when AI inputs the correct input. As we've already written the code for it, we can copy and paste it here, but write self period target number instead of target number. This is because in our previous code, we created target number as a global variable, but here we need to make it an object of a class, which is basically a variable that is accessible anywhere from the class. Just for you to know, if you need a variable to be accessible from other functions of a class, just write self and period before the variable. The reset function returns the observation, which is the information that AI can see and needs to decide an action on. In our case, it is the target number, so we return it. Then we need to create a code for the step function. The step function is called each time AI makes an action, and it does all the needed backend processes. For example, in our code, it is to check whether the action number is the same as target number, and then indicate success or failure, and reset the environment if needed. In other games, for example 2048, the step function will move all tiles in the direction that AI chooses. We have already written the code for it, and this is our while loop. Again, we can just copy and paste it, although we will need to edit it a little bit. First, we will replace all the target number variables with self period target number, and we will return it as observation. Then we will replace our call of reset function with a line done equals true. This is because in our code we needed to reset our game ourselves by calling a reset function, but here we need to indicate the end of the episode, which is the end of the game, and it will call the reset function automatically. On the video, I also forgot that in the beginning you should declare a done variable as false, to make sure that the game isn't restarted when it's not finished. Then we will need to replace our success and failure indications with actual numbers. We will give it a positive 1 for correct input, a negative 0.1 for incorrect. I also forgot that we can just delete the line where we input action, because the action will be passed to the step function. This function also returns info variable, which is some kind of information for the user. The AI cannot see it, and we won't need it for now, so we will replace it with an empty dictionary. Now comes the hardest part, the init function. We will need to declare action and observation space. Let me explain what they are. There are two main spaces that we will need in the beginning, discrete and box. You can understand them like this: discrete is one number and box is multiple numbers. Discrete space has one main argument, and it is how many values can be in that one number, starting from 0. So discrete space with 2 as an argument means one integer value that can be either 0 or 1. Discrete space with a value of 10 means one integer number with 10 possible values, 0 to 9. Box space is slightly harder. There are 4 main parameters: low, high, shape, and dtype. Low is the lowest possible value, and high is the highest possible value. Shape is the shape of the array of values, and dtype is the type of values. An example of box space is box with low value of -1, high value of 1, shape of 2, and dtype of float, and it will produce two float numbers with values in range of -1 to 1. Another example is the box space with low value of 0, high value of 2048, shape as 4 arrays of 4 values, and dtype as integer. This one will produce 4 arrays with 4 values in each, which will be in range of 0 to 2048. This may be an example of observation space for a 2048 game. Observation space is a space of observation values. For instance, the observation for a 2048 game is the board, so we will need to somehow pass it to the AI, which we can do by using a 2D array, where will be 4 arrays which will represent each line, and 4 values in each array, which represent a cell in the line. And the action space is a space of action values. For example, the action space of 2048 game is a discrete space with a value of 4, as the action is only one number with 4 possible values, 0, 1, 2, and 3, which represent up, down, left or right. So in our game, action is one value from 0 to 9, and observation is also one value from 0 to 9. I'll give you 3 seconds to guess what action and observation spaces should we write. The correct answer is discrete space with a value of 10, because as I said, it is one number and there are 10 possible values. Congratulations! You finally made your own reinforcement learning environment. This by itself won't do much, but it is a basis that you need to know to make your own machine learning AI. And this is what we will be doing in the next video. Thanks for watching and see you in the next video.